The last seasonality example we're going to look at is weekly data. Suppose if you have weekly seasonality and you want to predict or forecast on a weekly basis. So like if you have 52 weeks in a year, each week being a season, and then you have 52 weeks repeating. Okay. Now, of course, here some of the features of this is that each season is a very short time period. Okay. Typically, when you have monthly season or quarterly season, you have each season being a long duration of time, whereas here 1 week is a small duration. So because of that, even if you have a very large sample, you still may not have very many repetitions. You'll have very few repetitions of a given season. So if you have like 104 observations worth of 2 years, you have lots of observations. But a given week repeats only twice. And that has some limitations. And one more important feature or difficulty is the week, the special features of a week. For example, if you have Christmas, even a quarterly time series or monthly time series, Christmas is going to be in December no matter what, or Christmas is going to be in the quarter that's October, November, December quarter. It's not going to be in any other quarter. Whereas if you have weekly time series, okay, now the Thanksgiving, which is not on a particular, it's not fixed on a week. It could be the third week or the fourth week of November, and same is the case with Easter. So those are important feature weeks, and that may not fall in the same week year after year after year, and that could be a problem. And large number of series to be forecast. Typically, if you're looking at weekly, you're typically talking about several products, and you may have hundreds of products that you want to keep track of, and you have lots of time series that you have to analyze. So each stock keeping unit, SKU, for a retail company is an important consideration, and you want to forecast for each of them. So your computational task is really huge. So oftentimes what one might do is combine those SKUs and develop general features or seasonal effects, and then use those general seasonal factors into individual forecasts to make things simpler. So let's look at an example of this. Let's go to Excel file. So here we have 10 weeks. We are interested in forecasting a particular SKU. And this SKU is in a group of SKUs or items. And here are the annual sales for the entire group. And each product in the entire group, we are assuming that will have the same seasonal effects. So here we find the average sales over the 10 weeks. Okay. Now we're going to compute the seasonal factor based on the overall group and not the individual. So we take individual sales from the previous year, okay, divided by the weekly average. Okay, so then for week 1 factor, and the denominator should be absolute referenced. So now we can copy this, and what we have are seasonal factors based on group of products, the sales of group of products, not for the individual. Okay. Now we can use these seasonal factors to remove the seasonality. So we'll assume multiplicative model. So that means we divide this by the seasonal factor, and you get the adjusted SKU. And okay, so now we have the SKU sales converted, this seasonality stripped, not using the seasonal factors that we computed from this sales, but from the seasonality factor computed from the group sales. Now we can use the one step ahead. Say for example, let's say 0.1, and we use the, let's assume that the initial forecast is going to be the first uh, adjusted sales. Then it's going to be like previous forecast plus alpha times the error. So error is going to be, okay, the adjusted value minus that. Okay, so that gives us the forecast, and we can go all the way down here, and we go one step further, and we get the forecast for week 10. But this is forecast of the adjusted SKU. So to come up with forecast for the SKU itself, okay, we'll leave the first 2 weeks alone. Then you multiply that with the seasonal factor. And that gives us the forecast. Now we can compute the mean square error, and let's see, we start from week 4. So actual, comma, the forecast. Okay, and we use the same range, and we can do MAE, okay, MAPE, and RMSE. Then we can do MASE and Thiel's U. So MASE will be that and that. Okay, and 1 week ahead, so the naive forecast is going to be that. So this MASE is not really a good indicator because it doesn't, if it is weekly seasonality, then this is completely ignoring the seasonality. So obviously a seasonal model is going to do better. And Thiel's use the same range. Let's see how this compares with if we ignore seasonality at all.